So this is the final lesson in the book Samples and Populations, and really kind of wrap up of the whole idea of statistics and probability and just using those kind of concepts in real life problems. And so we're just going to look at some graphs and try to make some interpretations from them. And the sort of context we're going to use in this one is what's called Human Development Index and life expectancy. And there's actually a number that's calculated to report how well a country is doing overall in its human development, which means the idea of living a long, healthy life, access to education, and a decent standard of living. And so really this number is kind of basically a percent. And so when you start looking at these numbers, like an HDI, Human Development Index of 0.8 or above, is considered to be a high human development index. And in some ways you can think of it as where 80% above of the people have access to all of these things: long, healthy life, access to education, decent standard of living. And then the medium group is considered this between 0.5 and 0.8, 50 to 80% maybe of those people. Also a medium access to long and healthy life, education, decent standard of living. And the long and healthy life usually means access to health care and those kinds of things. And then the low group is below 50% or below 0.5 on this index. And so if you look at this chart and we want to describe the variability of the data in this chart, the data varies. You have anywhere from, and this is your life expectancy, so people that live to be 30 to 40, in this range, about 5% of those countries. And here, living to 40 to 50, this is their life expectancy. In other words, how long do people live? About 10% of the countries, that's people's life expectancy, 40 to 50 years, and so on, till you get to where 45% of the countries in this 177 country list have average life expectancy of between 70 and 80 years. And then there's a very small percentage, about 5% of the countries that have life expectancies between 80 and 90 years. So we're just interpreting the graph to begin with. The percents on the sides listed. So it varies from 30 to 90 years. That's the life expectancy. So that's one way to describe the variability, that life expectancy varies from 30 to 90 years. Another way to describe variability, you can always describe variability two ways in a graph, usually one in a horizontal direction, or oftentimes we call the X direction. A lot of different names for the independent variable, dependent variable. In this case, we're really just looking at a specific number, so 30 to 90 years is the variability in this direction. But then it also varies between about 5% of the countries and 45% with this one here. So you have 45% all the way down to the lowest, which is about 5%. So we have a couple of different ways of variation. It varies from 5% to 45% in the percent of countries in the bars, and then it also varies in terms of the life expectancy from 30 to 90 years. So we can always describe graphs in terms of their variability, and it looks in this case like the 70 to 80 is the largest cluster. So that's another way to describe variability, that the data clusters primarily in the 60 to 80, although with the 70 to 80 being the highest bar. And if we wanted to estimate the percent of countries that have life expectancy of 60 years or greater, so in other words, we want to estimate this one, and this one put together, we would just take the percents. This one's about 20%, and 45%, and 5%, and put those together, and you'd get about 70% of the countries in this case have a life expectancy that's greater than 60 years. So we're just taking these this percent, this one, and this one, and putting them together. And that's how we would answer those questions. So if we want to continue this, which we will on question 3, moving over to the next page. So now we actually have 3 box and whisker plots. So we've looked at all these different kinds of data. The first one is more of a histogram using a percent index. In this case, now we're going to look at 3 box and whisker plots. So we have the upper HDI group here, their box and whisker plots. And again, we're looking at life expectancy from birth. Okay, and so in this case, here's our upper group. You can see their median is close to 80, or the medium group, it's closer to 70 for the median. For the low HDI group, that median's around 45 years old. And so if you're kind of comparing life expectancy for the upper HDI group, compared to the medium HDI group, this group's life expectancy around 75 years, this group's life expectancy closer to about 68 years. So there's really about a 7-year difference, or 7 years less in this group. So that's our difference between those two. And really, if you want to compare that further down to this group who's around 45 years, now you're talking about a 22-year difference. So these people in the low HDI, the low human development index ratio, have a much lower life expectancy than people in the medium or high development index range. So again, we're just able to look at the 3 box and whisker plots and compare them to each other and see that obviously it's the high group, so we'd expect it to be high, and the medium and low group, and they're easy to compare to each other in this form in the box and whisker plot. And if we look at what we just did, there are these outliers here. And on the chart below, you can actually find those outliers. So we have an outlier somewhere around 35, 36. There's a couple of them. So this one right here, life expectancy, because our life expectancy between 30 and 40. So we've got a bunch of outliers in the medium group. And so looks like Botswana and Zimbabwe. And then we have another one that's a little over 40. Looks like Equatorial Guinea is another outlier, and a couple more closer to 45, the upper 40s, these ones here. So these 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5 asterisks, outliers. These are the 5 that actually represent the outliers in the medium group. You can see that the life expectancy, now they fit into the medium group because of their HDI, where their HDI sits. And so again, finding outliers, and they tend to be much lower than the rest of the data or much higher. And again, that's how we use box and whisker plots. And if we flip the page, we're going to look at one last type of data display that we just finished in most of problem 4.1 and 2, and that's a scattered data plot. And this one sometimes can be more confusing, but the idea is that if we take this scattered data plot and we locate a line through that data that goes through a point, and they're calling it through the line 0.01325x minus 0.166, and that's what I'm trying to do right here, is kind of get about minus 0.166, and really just not so much concerned about that spot as I am about drawing a line that goes through the majority of that data. So I kind of put my straight edge down so that it goes through most of that data. So by drawing the straight line, it goes through approximately those points. I know that this part is below 0 because of that, so that's why I'm down here, below 0. And that just gives me a way of sort of predicting, and this line then becomes my trend line through the scattered data. And so then I can use that to do that. And it says, how well does this line model a relationship between life expectancy and HDI? So we think about life expectancy is here, and HDI is here. So when HDI is 1, life expectancy is 90. It's sort of the maximum. And you have 100% access to all of those things, education, healthcare, then the life expectancy is 90. If you have, no access, then your life expectancy is less than 10 years. And so not much of a hope to live for very long if you have no access to those kinds of things. So that's a pretty good model of that. So again, if we talk about living for 90 years, the HDI should be about 1. So if you know life expectancy, you know HDI, but better than that, if you know HDI, the HDI index, you can fairly well predict the life expectancy. If an HDI is 0.60, you expect the life expectancy to be around 55 years. If you knew that HDI is 0.80, you would expect the life expectancy to be around 70 years. So again, the idea is I can use this data and this trend line to make general predictions. Not exact because of the scattered data, but in general, you can see especially as you get to the upper end, that data cluster is much closer to the line. As you're down lower, it's not nearly as good. And so that really represents all the different kinds of graphs and how we use them in samples and populations, and how to read them, and how to use them to write equations, and just all kinds of things that we will continue to do as we, in our future lessons, look more at lines and equations.